deploying a simple app using Docker and ECS. So guys, in this video, we'll be basically learning how we can go ahead and deploy a very simple app using both Docker and ECS. All right. So before actually we get started, guys, go ahead, give me a confirmation in the chat that you can hear me and that you can see the screen, and then we'll move ahead and we'll discuss the rest of the live session. All right, so while you guys are giving me the confirmation, I just want to show you guys something. So here at Great Learning, we have started an initiative called Great Learning Academy. So I request all of you guys to go ahead and check this out. It's an amazing venture we have started. It's especially great for all of those people who don't have the financial capability to get those expensive courses out there and get certifications with them. We provide similar courses, but they're completely free. So just go to greatlearning.in/academy and you'll find a lot of different types of courses like Python for machine learning foundations, and etc. We have a lot of different categories of courses also, and these courses are completely free, and you get a certification at the end of your course completion, and that certification is definitely going to help you in your career wherever you are aiming to go. Now let me just open up the chat and see if you guys can give me a confirmation. All right, so yeah, okay. So my voice is there, huh? So let me just go ahead and adjust that. All right, so I hope you guys can hear me much more clearly now. So let's start off with the session. So guys, in this session, we'll learn a lot of topics. So let me just show you what topics we'll go through. So we'll go through Docker overview, Docker objects overview. So basically we'll understand what Docker is and a brief understanding of it and what are the different objects. And then we'll understand why orchestration, because orchestration is important to when we are working with ECS. And then we'll move on to learn about Docker Swarm architecture and its components, then ECR, ECS, then we'll learn how to deploy, using ECS and ECR, and then Docker. And then, guys, feel free to ask questions in the chat. I will try to answer the questions you guys give me in the chat. And, while we are going through a lot of these different things, so I will try to answer your questions. Okay. So, okay, I see that we already have one question. Is there any course of web development too? Yes, you can go ahead and check it out. We have so you have introduction to full stack development that will basically give you an intro to web development. All right, so now that's out of the way, let's actually start. So what is Docker? So Docker is a containerization tool. So if you guys already know about DevOps, you might have already heard of the Docker, because Docker is a very popular tool. It is basically a containerization tool that helps us to create containers. Now containers basically help us to develop, build, test, execute, and deploy software. So it does so by shipping the whole software into smaller packages, and these small packages are your containers, and we actually deploy the containers themselves. Okay, so that's what Docker is in short. So what is a container again? So a containers are basically software that wrap up all the parts of a code and all of its dependencies into single deployable units that can be used on different systems and servers. So during software development process, you have a lot of systems through which the software is going to go through, because of all the different purposes there are. For development purposes, it's going to go through the developing computer of the developer. It's going to go to the testing server. It's going to go to the staging server. It's going to be built on a particular server. So all of those places, right? So we want to maintain consistency to make sure that the outside environment does not affect the inside code. So that's why we use containers. They provide a layer of isolation, and we can execute the code with its libraries inside of the container itself, because the environment we need to execute it is already there in the container, right? So that's why containers are very useful. And when you want to deploy software in terms of microservices architecture, right, it's very helpful when you have containers, because you can just keep all the different parts of your code in separate containers. Let's say you have one web application where you have 5 features, and all of these 5 features are individually located in 5 containers, and this container as a whole is connected to each other. They're integrated, and they talk to each other, they communicate with each other, and you deploy the this set of containers together. That's why containers are very useful. And now let's look at the Docker environment. So in Docker environment, you have a lot of different things. You have Docker engine that is basically responsible for doing everything inside of Docker. That is, managing all the objects, managing all the processes. And if you have any requests, it goes to the engine, and the engine processes that, and it gives you the output. This output can be creation of Docker objects. Now, Docker objects are basically, your containers, your images, your volumes, your networks. They're basically objects that you interact with to improve your, handling of basically containers, or, it serves the whole purpose of containerization. And then you have Docker registry, which is basically the location where you store images. And you have Docker Compose and Docker Swarm. So these are the different parts of your Docker environment. Now, Compose and Swarm. So Compose is basically used to launch multiple containers, and Swarm is basically an orchestration tool which handles multiple containers. Okay, so guys, I'm going very fast over here talking about Docker and everything. So if you want all of it in detail, please go ahead and check out my video on introduction to Docker. I have an introduction to Docker in both in English and in Hindi. So go to our channel, Great Learning, and just type in the YouTube bar Great Learning, and then type in introduction to Docker. And if you are the person who wants to listen in Hindi, I have a video for that also. Just type in introduction to Docker in Hindi, Great Learning. So I will explain all of these details in much more detailed manner. I won't just breeze through them. All right, so I hope you guys revised up with the environment. Now let's go ahead and discuss why orchestration. Now we're discussing why orchestration here because when we talk about ECS, that is an AWS service, orchestration is something we are going to be doing. We are going to be managing a set of different containers in a cluster. So that's why let's go ahead and discuss orchestration. So why orchestration? So in software development, right, if you do utilize or implement a microservices architecture where you have multiple containers containing, individual features of a particular software, it's important to manage that cluster. You want to manage that cluster in such a way that, you are deploying your software without any hitches, and you're able to scale up your whole product / service whenever there is a requirement for it, and you're able to remove or detach any particular microservices when it needs maintenance. And if you want to perform any updates on the whole system, you can do that using orchestration. And if you want to do any rollbacks, then there is orchestration again over there. So are there any prerequisites? Yeah, Amit Jain. So the prerequisites for going through this live session would be to just know basics of Linux, know about Docker, and AWS services is also good to know about, because we'll basically be using that, especially services like ECR and ECS. Okay, so now let's move forward. So orchestration allows us to manage and maintain multiple containers. This is especially helpful in software development where we may be making use of microservices architecture, as it breaks down the software into small manageable chunks. So if you have a software, you divide that software into smaller manageable chunks so that you can manage the whole software easily, because you have divided into smaller chunks. So whenever there is a problem, you can go to the root of that problem instead of searching the whole software itself. That's why we manage into but that's why we divide into manageable chunks, and that's what microservices is as a concept over here. Having different configurations and environments also becomes easier with orchestration. So you can have multiple different types of environments being connected to each other, and you can manage them by making use of orchestration, because orchestration helps you pinpoint all of these things. If there are any issues, then it goes to the root of them and it helps you resolve them, and it does so in a very fast way. All right, so now let's move ahead to talk about Docker Swarm. So Docker Swarm is an orchestration tool. So it's basically everything I just talked about, what an orchestrator does. So if you look at Docker Swarm is an orchestration service within Docker that allows us to manage and handle multiple containers At the same time, it is also a cluster of multiple containers. So it would rather be better to say that the swarm itself is a cluster of different containers. If you have 5 containers and you keep them in a swarm, that is your cluster. And to manage it, you make use of the swarm kit that is within Docker that helps you to manage all of these different things. So in a swarm, you usually have this kind of arrangement where you have one manager node and you have several worker nodes. So if you want to suppose launch a service, this can be a feature that you want to launch for your application. You have to do it from a manager node onto the worker nodes. So you do it on the manager node, and the manager node divides the task between the different worker nodes. So you guys will understand this better if I show you the diagram. You can see that the request from the user is given from the Docker engine to the manager node, and the manager node divides these tasks among the worker nodes equally. So it basically balances everything out, makes sure that the amount of task a specific task requires is given, is measured and is given to those who can only fulfill it. So let's say worker node 1, worker node 2 have different resources, that different availability for resources. The resource pool for them is different. Worker node has more resource pool and worker node 2 has less resource pool. So the manager node will accordingly divide the tasks, so that a task that requires a lot of resources will be given to worker node 1 because it has a bigger resource pool, and worker node 2 will be given a smaller task. Or then there's a chance, if worker node 1 is not idle, it already has a task, whereas worker node 2 is idle, so you give the task to worker node 2. So that's what happens. A manager manages all the different workers so that these workers can perform the tasks. It's like having a normal hierarchy in any sort of organization or company, where you have a manager who makes sure that the workers do the specific tasks that they've been assigned to. All right, so I hope that was clear. Now let's move on to see what AWS ECR is. All right, so I have a question in the chat. So what is the difference between Docker and DevOps? Anand, so Docker and DevOps is not something you would differentiate between. Docker is a containerization tool that you basically use to create containers. Now DevOps is a methodology, or it's a mindset that people use when they're developing software. So you can consider DevOps a lot of the different things, but just understand that DevOps is kind of like a methodology. It's a improvement upon the traditional methodologies we have, and it is used in unison with them. Like you have Agile. Agile is used with DevOps. So when you talk about DevOps, DevOps is basically developers and operations teams job mixed together. So they are basically, if you're a DevOps engineer, you're a jack of all trades, so you know everything about the whole system. And the job of a DevOps engineer is to make sure that the whole software pipeline is as optimized as possible, and automation is involved in every process. So that's what you do when you talk about DevOps. But it's not necessarily that. It is also the mindset that people use in a company when they're developing software. You try to remove silos away from everything, and you try to make sure that responsibility of the final product falls onto every person who's involved in this whole process. Can you explain about, okay, so that, I hope that was clear for you, Anand. Now just go to another question. All right, so Ajay is asking, can you explain about zero downtime deployment and high availability using Docker? So I think you're asking about Docker as a if you're asking about Docker as a Docker swarm with the high availability and zero downtime deployment, then so basically it's important to make sure that your application that you finally deployed or to the end user always has high availability. That means that the end user has access to that particular product or service all of the time. And if if it goes down, then if the application for some reason crashes because maybe you put up a new update and that new update didn't integrate very well with all the other features and it crashed the whole app, so then your end application will not be available to the end user. So that will be called the downtime. So you have to make sure that the downtime is almost zero. So that's why we also make use of faster automated processes. So we if the whole application goes down, we go back, take the most stable version and push it so that the developer or the end user has something to use. All right. Okay, guys, keep your questions for a little later. In the end, I'm gonna check them again, or just keep on asking. I'll just answer whenever I get time because I want to cover this topic also. So let's continue with AWS ECR. So what is AWS ECR? So we talked about Docker registries, right? So AWS ECR is basically a Docker registry. If you have Docker images and you want to store these Docker images, then you make use of specific Docker registries. Now, normally you would use Docker Hub, but we are going to go make use of AWS's own Docker registry, that is ECR. The full form of ECR is Elastic Container Registry. It is an AWS service. So AWS over here is the Amazon Web Services. It's a cloud provider. So they give us a lot of services on their cloud platform. So ECR over here, it is an AWS service that acts as a dedicated location for storing Docker images. Now we know that Docker images are basically used to create containers. So we don't share containers with our teammates or whoever we want to. We share images so that they can run the images on their own system. So to share it, we make use of Docker registries. Similarly, we have ECR. Once a Docker client has been authorized, it can pull and push to and from the ECR registry. So again, with Docker Hub, you just had to use the command Docker pull and Docker push because it already knew by itself. But with AWS ECR, it doesn't know that. So we have to go ahead and tell Docker that you have to work with ECR, and we have to allow authentication of our Docker host or the Docker client that we're using on our system. So there's a specific command. We will learn how to use that. Now it is useful in a scenario when you don't want to manage dedicated storage images and you want to use other AWS services that make use of the image you have. So it is very useful to have. It's actually beneficial to use AWS ECR instead of having your own server to host images, because if your organization is handling a lot of services within AWS itself, maybe you're making use of EKS, that is Elastic Kubernetes Service, or ECS, Elastic Container Service, then you don't want to use your own dedicated server because you have extra things to manage. You would rather use ECR because it's already managed by AWS, and you can use it to reference your images on ECS or EKS and launch your application. So it becomes very easy to do that because a lot of authentication steps are reduced when you are using a home built registry within AWS itself. All right, so again, let me show you guys Docker registry. So once again, there's if possible, can you please go through the logics? Let us know. Okay, Paramveer, I'm going through a little bit fast because the demo is going to be a little longer. So if you want to check out about Docker in detail, I would suggest go ahead and check out our video on Docker. That is Introduction to Docker, where I talk about Docker in detail. So once you get to know about that, you can come back to this session and watch it as a video when it gets uploaded as a video later onward. Okay, so don't worry about it. All right, so let's continue. So ECR is a Docker registry. You can think of registries as storage locations for Docker images. So you have AWS ECR, you can store different versions of a Docker image like image 1, image 2, image 3. And once you store them, you can utilize it anywhere. You can even have other people access your registry and use it for their own purpose. You can have another developer from another team or a developer from your own team accessing the images you have. All right, so now let's talk about AWS ECS. So AWS also provides a service called ECS. So ECS's full form is basically Elastic Container Service. Now this Elastic Container Service is an AWS service. So again, just like ECR, it is something that the AWS platform gives us. So instead of launching or having our own on-premise hardware where we have our own server running, we can make use of AWS's ECS service where we can orchestrate a software deployment. So generally before cloud was a big thing, people used to have their own on-premise hardware where they launched servers and they made it accessible through the internet, and that's where they deployed their software. But to remove that all of the hassle of keeping and maintaining your own servers, what you can do is just make use of ECS, that is Elastic Container Service. So which basically does not require you to maintain any of on-premise hardware. You just have to make use of the services that AWS is providing you, and they will take care of they will take care of all of the maintaining and keeping up. All you have to do is just pay them. Now we'll be using the free tier version, so don't worry about paying. I just mentioned this because big organizations have to pay for the services they use. Now it acts like any other orchestration tools like Kubernetes or Docker Swarm. So we have tools like Kubernetes and Docker Swarm, which are orchestration tools. Again, orchestration tools basically help you to orchestrate a set of Docker containers or containers in general. And ECS does the same thing. So it basically does the same thing, but it's a direct service that AWS provides us. And EKS is also something similar to this. It is Elastic Kubernetes Service. So you make use of Kubernetes in that. It allows us to deploy, update, roll back, scale up our software deployment. So it does all of these things that a normal orchestration tool does. So now let's talk about what are the different things we'll have to define when we start using ECS. Now it's gonna get a little overwhelming. Try to keep up, guys. Okay, so ECS, like I said, is a service and it allows us to orchestrate. So inside of the orchestration, when you want to, finally deploy your app, right? How will you do it? So there are 4 layers of configurations slash definitions you have to do when you basically launch up your cluster and you deploy your software on that cluster. So first you have to do the container definition. Inside of the container definition, you're basically providing the image that you're going to be using for your final application. So let's say you're using 3 images for 3 of the features that you have. Then you basically mention all of those 3 images in your container definition. Then we move on to task definition. So task definition is basically the specification of what kind of resources will your containers be using. And then we have service definition that basically tell us how many replicas or how many instances of a specific container we want. And then finally we have cluster definition that is basically forming the infrastructure, that is the platform or the stage on which we will launch our software. So you guys will get a little bit better understanding when we actually do it. So it's okay if you're a little confused right now. All right, so this is the basic diagram of how things go. So from ECR, we'll be pulling our images onto ECS, and then we'll be making either use of Fargate or EC2 technology within ECS. So ECS makes use of other services also. It makes use of ECR and it makes use of EC2 and Fargate. So Fargate is basically, okay, let me just give you guys EC2 and Fargate. So to do that, what I will do is I will come back to my AWS management console over here. So I'm right now in EC2 dashboard. So EC2 dashboard, if you guys have seen any of my previous videos, I am basically launching a server slash instance of Ubuntu on which I can start doing my work, right? So it's like a virtual machine that you're launching using the virtual cloud. This is the cloud platform that we have over here. So EC2 is that. EC2 basically allows us to launch virtual instances that we can make use of. Now, even during deployment, Amazon EC2, instances are used. That's why their EC2 is over here. So you can choose between EC2 and Fargate. Now, the difference over here is that Fargate is completely managed by Amazon, whereas EC2 has some configurations of the infrastructure that we can manage. So you don't have to manage any hardware components with EC2, but you can SSH into these instances and configure them in such a way that they benefit your requirements as much as possible. But if you don't want to manage any of those virtual machines themselves, you just want your software to be deployed, then you go ahead and make use of Fargate, because in Fargate you don't have to worry about what kind of configurations are there in the EC2 instances. You just worry about what kind of software you're going to be launching, and there is a little bit of slight difference that I'll talk about when we are actually doing it. And once you put your software on the cluster, then you go ahead configure a load balancer, because you might have multiple replicas of a certain feature, and if to connect them all together, you need to make use of a load balancer. Okay, so this is the basic diagram of what we will be doing today also. So first we'll go ahead and create a Docker image, we'll upload it to ECR, then we'll use ECS, we'll use either Fargate or EC2, and then you'll use a load balancer, and then we'll access the website. So let me quickly go ahead and start up our instance over here. So I'm going to launch instance. I'm going to be using Ubuntu over here. So I'm doing this because what we want to do first is we want to go ahead and create our image that we want to upload onto ECR. So for that, I will open Ubuntu over here. Now, if you already have an image with you, then you don't necessarily have to do this, but just follow these steps. So go ahead and launch an Ubuntu instance. Now, if you want a detailed guide on to how to launch an Ubuntu instance, watch one of my previous videos where I do explain all of this. Docker image creator. Okay, so I've created this. Now let me just open 2D up. We'll wait for this instance to load up. Till then, I'll just check out the questions. Okay, so we have a question, what is Kubernetes? So Manoj, Kubernetes is a bit like Docker Swarm. It's an orchestration tool. So if you know what containers are, and if you know that containers used to deploy your software, when you have multiple containers, if you have 6 7 containers, how do you manage each of them? Like, what if you want to update all of these 7 containers at once? Then you make use of orchestration tool like either Docker Swarm or Kubernetes. So that's what Kubernetes does. So Harsha K has a question. ECS is basically what Kubernetes does. Yes, it's similar to that, but not exactly that. Okay. All right. So let me launch this instance up. Copy the IP address. All right. So we're going to go ahead and create our Docker image. So for that, I want to install Docker over here. Okay, so Harsha K has another question. Will we have containers across different EC2 instances? Yes, we will have containers across the different EC2 instances, and the load balancer will route to these EC2 instances. So you have to, create a target group, and we will check how to do that. And these EC2 instances can be in different region, but you know, uh, if you want them to be in different regions, you can do that. But let's see how we will go ahead with it. Right, so we have Docker installed, Docker hyphen version, we have Docker installed. Okay, so now what we're going to do is I'm going to create a new folder project, and inside of this folder I'm going to go ahead and create a new file called nano index.html. So my file is going to be index.html. So we're just going to use some random code over here, the HTML code. Okay, so we have a sample code. I'm going to go ahead and save this. All right, so now we will go ahead and create our Docker file. So when we want to create an image, we make use of a Docker file. So what I'm going to do is I'm going to copy. So actually I'm going to use a base image, Nginx Alpine. Okay, and then I'm going to copy my index.html to user share Nginx HTML. So basically what I'm doing is I'm running my sample website on the Nginx server. So if you want to do it, then you have to do this. You have to paste your .html file in this particular location. So that's what I'm doing. I'm using this as the base image, and I'm copying my file to this location. So I'm going to go ahead and save this Docker file. My next step is going to be building this file. So docker build -t. I'm going to give it the appropriate name. I want it to be version 1. Dot. So it will start building my Docker file over here. All right, so if I do a Docker images, I should see two images. We have our image with version 1, and we have Nginx, because it had to pull the Nginx image to create our customized image. Okay, so now we have basically created our image. All we have to do is basically push our image onto our ECR repository. First, before we do that, you guys should make sure that a specific IAM role is attached to your this thing, Docker EC2 instance. Sorry, yeah. Just if you don't, just click on Docker on the EC2 instance you have created. Click on Actions, Instance Settings, and click on Attach and Replace IAM roles. Then you can choose a role over here. I'm gonna show you guys how to create a new role. So I'm gonna click on EC2 ECS role. Then if you don't have one, you can click on Create New Role. By then I'll apply this. All right. So IAM role is basically, what kind of user gets what kind of access. So we want to make sure that, our ECR can access this properly. Okay, this is taking way too long. All right, so here, yeah, you can go ahead and click on create a role and choose AWS service EC2 Lambda. You can click on EC2, click on next permissions, and make sure that you have ECR access over here. Just type in ECS access, ECS full access, and EC2 full access. All right, so once you're done, just click on next tag, configure all of the other things, and then create the role. Okay, so now that we've done that, click on services, and here we're gonna start the main part of our whole thing. That is, type in ECR in services, and you'll find Elastic Container Registry. Click on this. So it's going to take us to the container registry. Right, so we don't have a container registry. We have to create our container registry first. So let it load. All right, so click on get started for create repository. We'll name this, I'm going to name this Docker repo. And then you can click on create repository and it will create a repository. So creating the repository is one of the simplest parts. You just have to create the repository, give it a name, and just create it. Now over here, you want to basically select this and click on view push commands. So when you click on view push commands, it will give you basically the steps to basically upload your Docker image onto your AWS ECR. So first is retrieve an authentication token and authenticate your Docker client. So we're going to go ahead and copy this command. So this is what it's going to do. Also, we need to basically install AWS CLI, because it asks us to use AWS CLI. So we have to go ahead and install AWS CLI. So we're going to do apt install AWS CLI. Right, so made a stupid mistake. Let me add one more L. Oh no, actually one L, it works. All right, so yeah, it was double L. I had a brain freeze moment over there. Don't judge me. Okay, so it's basically downloading the AWS CLI. So AWS CLI is basically the AWS command line interface. So you can run all the AWS commands from your instance when you've installed AWS CLI. Then we will use this command. So this will basically authenticate our Docker client to AWS. Make sure that you copy the exact command. You can just click over here. And after this is done, we're going to paste the command in and press enter. So it should basically show you login succeeded over here. Now once you get this login succeeded, we can move ahead and basically start pushing our Docker image. Now we already have created a Docker image. So let me just type in Docker images. We'll close this and copy the URI of your repository. Okay, so what we're going to do is we're going to tag this with a different name. So I'm going to use the Docker tag command. We're gonna type in HTML web nginx, we can copy the URI and paste the URI. So basically we are renaming it with the URI of our repository. We press enter. Right, so make sure that if you've included if you've included your version 1 as the version, then you have to include that. Okay, so if you do a Docker images again, so I wrote colon version 1 over here because when I created my image, that this is the name I gave it. So you can see tag version 1. Okay, so now we can see our new name of our image. Now what we will do is we will go ahead and push this. So I will type in Docker push and the name of it. Let me press enter. So you guys can see that it's the push refers to the repository where it's pushing to this repository. And if we come back over here and if we go inside Docker repo, we should see our image inside of it. We'll wait for it to load. And yes, so we have successfully pushed our Docker image onto ECR. All right, so this is one of the first steps completed. We pushed our image onto ECR. So actually this is the second step. The first step for us was to basically create our Docker image, and the second step was to basically push our Docker image onto AWS ECR. So we had to basically attach IAM role to our EC2 instance, and then we had to authorize it. For that we had to install AWS CLI, etc. Okay, so now we have uploaded our image. Now we can basically go to ECS. Now there are two ways. You can already see that we are actually inside Amazon Container Services. So you can just click on Amazon ECS over here, or you can click on services again and type ECS over here. You'll get Elastic Container Service. You can see that it reads highly secure, reliable, and scalable way to run containers. All right, I want to see if my image is running at all or not. So if I do Docker images, let me actually check if my image is running at all or not, because if it doesn't run, then there's no point in doing all of this. So Docker run -it-d. I'm going to publish this on the port 8080, and we're going to use the this name. Press enter. Right, so we need to basically just ignore this command, guys. Okay, so we don't have any containers created. Okay, so let me just bring that command up again. Okay, so make sure that you add the whole name, that is v1, that is a version of your image also. Okay, so press enter and you will see your Docker container running. So yes, it is running. Let's make sure it's up and it has not exited. Hooray, it's not exited. So I can check over here itself. Let's do a local curl the local host, since it's on the local host. Okay, so we can see our container is successfully running. So our website is successfully running on our basically on our host system. You can also check this by checking out your EC2 instance's IP address. You paste it in the browser. Oh, it's loading. Forgive my internet, it's a bit slow. So I'll read some question. Okay. Okay, so over here, we'll copy the IP address, paste it. You can see that my website has been launched. Okay. All right, so let's go to ECS finally. All right, so there are a lot of different things. Let me start off by showing you guys this. So Amazon ECS makes it easy to deploy, manage, scale Docker containers, running applications, services, and batch processes. ECS places containers across your cluster based on your resource needs, and it is integrated with familiar features like elastic load balancing, EC2 security groups, EBS volumes, this for storing data, and IAM roles. So you can see that a lot of different AWS services are basically working together to form the basically help you deploy your application or website. Let's click on get started. So this is easy for beginners. So over here you guys can see again how the definitions happen, the layers of how it happens. You have first container definition, task definition, service, and cluster. So container definition is basically choosing an image for your container. So you guys, if you guys are working with this, just go ahead and choose any of the random ones. Or if you've created a container with me, you can click on configure over here for custom image, or you can choose sample app on Nginx. Over here, I'm going to give this the name simple, or let's say sample website. Or no, I want to give it a name awesome website. And the image has to be the basically the URI of your image that is on Elastic Container Registry. So for that, we just need to copy the URI of the image. Till then, we'll give it the memory limits. I'll give it 512 MBs. Port mappings, we're gonna give it 80. So over here, you guys can see it's written container port and the protocol. It's not given the host port because we are not managing it at all. So by default, it's going to be exposed at the default port, that is the IP address itself. We can configure this to be different if you want. All right, so let me copy the image URI. I'm going to go ahead and paste this over here. All right, so these are the main details you want to configure. Now there are more advanced details. We're not going to go through them. So we're just going to go ahead and click on update over here. So we can see our awesome website now as a part of the container definition. Now we get the task definition. Now task definition is blueprint for your application. Describes one or more containers through attributes, and some attributes are configured at task level, but majority attributes are configured per container. So you have details like the network mode you're going to use. Now we are actually working when I clicked on getting started, it made us start with basically Amazon ECS using Fargate and not EC2 because Fargate is a little bit easier to use. That's why we are using it. And this is if you click on getting started, right? If you didn't do it manually, then it gives you the most easiest UI to help you out. And it's already configured a lot of things that we don't need to change right now. As you can see, we don't really have to change anything over here. It's already given everything. So it's going to create a new task execution role to execute this task. It already has a network mode for AWS VPC. Now, if you were using EC2, then you can change the network mode also. You can choose other things, task memory, task CPU. So you get to assign it if you're doing it by yourself manually. So let me click on next. So do we want a load balancer? Yeah, we can go ahead and click on this load balancer over here. So it will automatically create a new load balancer for us and even a new security group. So it's going to be doing everything for us. So I recommend you guys also use the getting started option. And then click on next. Cluster's name, we're going to give this a different name. Awesome cluster. All right. So this is the cluster configuring cluster. So within service, we had configured what kind of load balancer would be used. And you guys can also see in cluster service that number of desired tasks. We only can have one task. That means only one replica. And this is, not something that is desirable normally, but, we are just right now deploying, we just want to deploy our website on ECS. Simple, Then click on next again, give the cluster name, and it will start creating all of this. So before you create it, you can review all of your details. Click on create. All right, so it will start creating all of these. So it's going to take a few seconds for this, or maybe a few minutes. So I'm going to go ahead and answer any questions you guys have. Okay, so we have some questions over here. Okay, so Ravi Shankar has a question. So one question, the AWS ECR repo name and the Docker image should be same. And in this case, is it Docker repo? Okay, so they don't have to be same. What I did was, I created my repo first. I gave it the name Docker repo because I wanted to give it something relevant, right? I can give this even, awesome repo also if I wanted to. And all I did was basically copy the URI of my repo, and I tagged my Docker image with my URI. So this was my Docker image, right? I just tagged it with the URI of the repository, because when you want to push an image, you need to push an image to a certain repository. So that's how you do it. This is the step you have to follow when you want to push an image onto a certain repository. Even with the Docker Hub, the nomenclature is a bit different. You have to include the username and then the name of the image, right? So that's how it goes. Now you can change the image tag. All right, so now I hope that was cleared. Well, let's check out any more questions. Okay, so I have a question over here. Why Nginx Alpine and not G Unicorn? Well, I use Nginx because I felt Nginx is very popular and it's very easy to work with. And I have not worked with G Unicorn, so that's why I did not use it. Okay, so Yogesh has a question. Other than Docker, is there any machine learning deployment tools? So as far as my knowledge, I'm not exactly sure, but you can, even deploy machine learning tools. Like if you have a software that utilizes any machine learning abilities, you can definitely deploy it using Docker. There's no limitation over there. This limitation is your creative mind, how you can do it. How does ECS scale? Okay, so ECS scaling. So do you want to see it happen, or is it like a conceptual question? So I'm going to answer it conceptually over here. So ECS scale, right? So you can configure auto scaling, or you can give a predefined thing. So if you do auto scaling, it will automatically detect it by itself. Like if there are a large number of requests hitting your website, then it will automatically scale it up. Yes, Ravi, you can go ahead and use AWS ECR completely for free. All of this I'm doing right now is completely free. I'm not paying for a single dime. I'm not paying a single dime over here, a single rupee. Okay, so our service and our cluster is complete. Now we can view our service, and you guys can see a lot of different things over here. So don't be overwhelmed. I'll explain everything to you. So I'm first going to click on Awesome Cluster. We're going to go back a little bit, and in the Awesome Cluster, you guys can see a service that is running. So our service is active. You need to make sure that the service type is a replica. So service basically defines how many replicas you'll have. So one was the only desired one, and one is running. And the launch type is Fargate. That means we're not managing any of the EC2 instances. If you click on tasks, you can see that we have one task running with a automatically created task definition. And in ECS instances, right now we don't have anything. You guys can go ahead and check the metrics and everything. Let's go back to services, because then I'll show you guys services. I'll show you guys how to basically access your website. So you can directly check out the tasks IP and access it using that. But since you have created a load balancer, we can just check out a load balancers DNS and access it using that. Okay, so Manoj asks, is why is ECS Fargate instead of EC2? So because that's when you get started, right? That starting option when you check out ECS for the first time, it wants you to get acquainted with ECS. So it basically uses the easiest version, that is Fargate, and it configures everything for you. You can also use EC2 also if you wish to. I'll show you guys how. First, let me just show you how our website is deployed right now. So it's opening up the EC2 management console, target group, then we'll check out the load balancer, and then we'll get the DNS. So this is a load balancer. Now normally if you're working with ECS, right, and you do everything manually, you have to create your own load balancer, but since we're getting started, it created a load balancer for us. So let me just answer a few more questions. Tapti, I have not worked with machine learning deployment, but since you are, so keen on knowing about this, I will confer with my colleagues who are expert in that domain, and try to come up with a session for later purposes. It's a very good idea, and if you're interested, then go ahead and comment on this video once you're done, and we'll keep it in consideration. All right, guys. While it's all loading, you guys can go ahead and ask me questions, because then it will take way too long if I wait for you to answer in the end. All right, so we have our load balancer over here. Copy the DNS name over here and go ahead and paste it. All right, so now that we pasted our DNS name here, you can see that my website has been deployed successfully. So this is how you would use ECS on a very basic and simple level. Now I want to show you guys how to basically go ahead and use the clusters and create it by yourself. Okay, we have Manoj answering. Yeah, AWS SageMaker is used. Okay. Yeah. Thank you for letting Tapti know. Okay, so let's go to first task definitions. So actually, we go to clusters. Task definition. Load. All right, so we will start off by creating a new task definition itself. So this is automatically created. So what we will do is, we will try to do it ourselves now. So doing it ourselves will be a little longer process, but let's go ahead and do it. Create a new task definition over here. So I want to show this to you guys because then you will understand how it works. So here, when you create a task definition, it asks you for a launch type. So over here you can see Fargate and EC2. With Fargate and EC2, it tells you all the differences also. So the Fargate, right? When you work with Fargate, the price is based on your task size. So depending upon how big your applications are going to be and how big your tasks are going to be, it's going to price you on that. But whereas with EC2, the pricing is based on how many resources each EC2 instances is using. All right, so and this requires network mode AWS VPC, and EC2 requires multiple. It has the availability to use multiple network modes. With AWS manages the infrastructure, no Amazon EC2 instances to manage, like I said earlier, and with EC2 instances, self-managed infrastructure using Amazon EC2 instances. So let me just show you guys with Fargate again. This configuration will take a lot more time. So let me just show you guys Fargate. It's very similar. The only difference is that you just get to manage and SSH into your EC2 instances in this than with Fargate. So click on next step, and we'll give it a definition, task definition name. I'm going to give this awesome, or let's give it a new name. Let's give it beautiful task. We're going to give it task role. So task role, guys can go ahead and choose ECS task execution role. So this is a IAM role that can use to make API requests to authorize AWS services. So if you make use of other AWS services like ECR or any other service, then you can go ahead and use your ECS task execution role. Then network mode you can leave as AWS VPC, and I don't think you can change it because it's Fargate. It has only one mode, that is AWS VPC. All right, so task execution IAM role, we're going to leave it as default. Task size, we can go ahead and make this 0.5 and make this 0.25 CPU. So as you guys can see in a task definition, we are defining what kind of network mode, what kind of task execution role, and what kind of memory and CPU needs to be used. So the task size allows you to specify a fixed size for your task. So you'll be priced basically based on your tasks, right? So task size required for tasks using Fargate launch type and is optional for EC2 launch type. Container level memory settings are optional when size is set. Task size is not supported for Windows containers. So this is for Linux containers. So let me go ahead and add our container. So you guys can see container definition. Now container definition is the over here. So let me go ahead and give this name again. So to differentiate it, I'm going to name this beautiful website, and we're going to copy the image URI again, paste it over here. We don't need private repository authentication because it can directly access AWS ECR without any problems. Again, we will set the memory limits to 512 MB. So this is like limits for how much your container can use. Then over here again with port mappings, you can see that only container port mapping is necessary. Host port mapping are not valid when the network mode for the task definition is host or AWS VPC. So that's the case with Fargate. Okay, Fargate already does all of it. So let's go ahead and click on add. Then service integration, we don't need to configure all of these. You can go ahead and add a volume also if you want. You can choose the type of volume, bind mount or EFS, give it a name, and you can configure all these details. Okay, Let me just cancel this. I'm not going to need this right now. I'm going to click on create. Also guys, if you want to configure all of these data in JSON, you can do that. Just click on configure JSON and you can manually change all of these things. If you're a person who's more enthusiastic about doing it manually, then you can go ahead and change all of the details over here. And you can see that all of the details are the same. It's just you're changing the JSON values over here. I'm going to use the GUI itself. Then I'm going to click on create, so it will start executing the new task. Then we can view the task definition, and we have a new task. We can create new revisions for each task for new purposes. If you have new software that requires more space or more things, then you can go ahead and revise it. And you can go ahead and use a new service for that. Now we have a cluster already over here, but I'm going to go ahead and create a cluster to show you guys how you can do it by yourselves. So over here in cluster templates, you can choose different cluster templates. So you can choose networking only. So here you don't have to worry about the EC2 instances that might be created. This is powered by AWS Fargate again. So we're going to go ahead and click on this. If you're working with EC2, then you need to go ahead and configure EC2 Linux plus networking. So for Windows, it's separate. Click on next step. So cluster name will be beautiful cluster. Now we can go ahead and create a new VPC over here. For this, if you guys don't want to configure it, you can just leave it empty for now, and we'll just create a container cluster. So now cluster is created. Now we can view the cluster. Alright, so we don't have any services running on this, so we don't know how many number of tasks we want to run. So we're going to go ahead and click on create service. So again, I'm going to choose the launch type as Fargate. Task definition is automatically taken as beautiful task. We can change it to first run task, but we'll leave it a beautiful task. It has only one revision. Then the cluster is beautiful cluster. Service name can be beautiful service. Number of tasks, we can now define the number of tasks unlike previously. So I'm going to name here 3 tasks. So we're going to have 3 replicas of our task. That is our container. And if we scroll down, we will leave all of this as it is. Deployment type, we can keep it as rolling update. Click on next step. Alright, so cluster VPC, we can go ahead and choose this one, subnets 2B and 2A. Now if you want to create a load balancer over here, you can do that, but right now we're not going to create a load balancer because that is another 30 minutes of process, and this is supposed to be a 1 hour session. I'm sorry guys, so we're just going to leave it none, and I'll show you guys how to directly access from the instance itself. And we can go ahead and click on next step. And here, so one of you guys asked for auto scaling, right? So this is where you can configure auto scaling. So you can configure your service with auto scaling, where you can have minimum number of tasks. You can set it to maybe 2. So suppose the number of hits that you're getting to your website is reduced a lot, maybe you can change the number of tasks to 1, so that you don't eat up a lot of resources. And if you start getting a lot of hits and your current infrastructure can't handle it, so you can increase the number of tasks to 10. So over here, automatic task scaling property policies. You have target tracking and step scaling. So there are different types of policies that you can enable. Right now, we're just going to click on do not adjust the services desired count. I only show this because somebody asked for it. So I'm going to click on next step, and you can review your service. Then click on create service. So your service will start getting created, and we'll click on view service. Alright, so we should have 3 tasks running over here. We have 3 tasks. Well, it's being provisioned right now. So we'll wait for this to get refreshed. We can refresh over here. And if the status changes to running, we can go ahead and view that status. So right now it's pending. So we have running count 2. Alright, So guys, we have successfully deployed our web application on our ECS. We have multiple tasks running. We can click on one of these tasks, and it will take us to the details of the task, and this is the IP address, public IP. So if you guys want to access it, just go ahead and copy this IP and paste it and go, and you can see that the website has been deployed successfully. Okay, so we should have ideally included a load balancer also. So just in case, if you guys want to know how to create a load balancer, just go to EC2 dashboard and scroll down. On the left hand side, you'll find load balancing. So click on load balancers and go ahead and click on create a new load balancer, HTTP, HTTPS, click on create this, and you need to enter a lot of the details over here. Okay. All right. So guys, that was it for this session. So let me just reiterate what we did in this whole process. We basically deployed a very simple app using ECR and ECS. So what we did was we created our own image, Docker image. It was a simple website. Well, it's an image for launching a simple website. We uploaded that image onto ECR, and then we basically created ECS Fargate service where we reference a ECR image and launched a image. Now you can make use of load balances if you have multiple replicas, and load balancers basically divide the tasks, divide the hits on different tasks, so that you can equally based on how many resources one has available, based on that it gets divided. If one crashes down, the other is still available, so that improves our availability of our website also. So guys, this was it. Now I want you guys to give in some questions. I'll answer a few more questions and then we'll end the session. So let me just scroll up. Okay, so we can install Docker on existing EC2 instance where already a project is running. Yes, you can go ahead and do that, Pramod. You can install Docker on an existing EC2 instances if you want. What's the difference between task size and resource usage? Okay, so with resource usage, it's basically how much CPU you're utilizing and how much memory you're utilizing. Where with task, it is basically the size of the containers that you're deploying. As far as my knowledge tells me that task size is basically your how many containers can you launch at a specific time. So if I improve the task size, then I can launch multiple more containers. With resource usage, you have EC2 instances on which your containers are running. So how much resources each EC2 instances is consuming. So task size is more direct, whereas resource usage is a little indirect. All right, guys, thank you so much for watching the session. I hope you really enjoyed or really understood what was taught to you. Please go ahead and subscribe and hit the bell icon and comment. That really helps. And I'll see you guys in the next live session.